All right. So, hello everyone. This is going to be a presentation about how to not lose your code anymore. Basically, Git essentials. My name is Erick Garcia, and I'm a lead Android developer, currently working at Kaiser Permanente. So, a little bit about myself. I'm very passionate about all things Android, especially since it's a derivative work from Linux, which I have used for many years and several distributions. I like the flexibility that it has and how it empowers you to do more. The beauty of Linux is that you can find it on your smartphone, on your toaster, on your fridge, on your temperature control, on your TV. It's just everywhere. And it's like a very important part of our lives, even if we don't actually know that it's there. Some of my other passions is I'm currently based also in Colorado. So I'm very passionate about the mountains. And right now we have the aspen trees changing colors to being golden, just like in the picture in there. And it's just marvelous. So I'm especially during this season, you'll find me hiking in the mountains during the weekends. Other than that, I'm somewhat of a green thumb. So I actually grow like tomatoes and have a few trees back home. And I'm always looking to explore like new plants to make tea. Final but not the least, I love sports. So on my free time, I also do a lot of tennis and some longboarding. To connect professionally, there's my LinkedIn. Feel free, anyone that has any question or would like to do any kind of follow-up, feel free to reach out right there in my LinkedIn. I'm more than happy to chat about anything Android, coding, even sports. So there's my LinkedIn. Feel free to reach out. One more thing, I also like to mentor, like on my free time, I mentor people that are getting started. So feel free to reach out as well if you have any question about Android in general or today's topic, Git or version control systems. So let's start with what is a version control system, shorthand VCS. Formally, Atlassian, one of the companies that is behind some of the most popular tools for version control, defines it as software tools that help software teams manage changes to source code over time. There's also the Git SCM, which is basically behind, they have like large Git documentation that defines it as a system that records changes to a file or set of files over time so that you can recall specific versions later. And then we have the way I would describe a version control system as a system that distributes a copy of the code to everybody so we can make changes, but also keeps track of the individual changes so we know who to blame when things go wrong. So in a summary, most projects, especially like software projects, contain the lines of code that are required to generate the software, right? And in the past, people used to have those changes on their own computers and used to share them with everybody on a need-to-need basis. Just like we did when we were like in school, and we used to have like everyone will have like a copy of the assignment, and there will be someone like at the end trying to merge all the paragraphs together. Now with a version control system, it is a tool that will help you group your code together in an easier way. And we're gonna see exactly how does it do that. Now, version control systems, there's two main types of systems out there. One, which is the centralized, that used to be used a long time ago. Like it was one of the first systems that went out there, where everybody will log in to a server and make changes directly to the database or to the control system. So that means when you went and made a change, immediately everyone else will see the change. There's another type of system which is called distributed, which is how Git is based on, how Git works, and some of the newer version control tools work, which is instead of being a server that has everything that everyone connects to, right now, these tools, what they do is they connect to a server and they download a copy of the database, a copy of the source and the history. You have a local copy of everything on your computer. And then these copies communicate with each other to share, to distribute the changes. So there's major differences between these two types of systems, the centralized and the distributed. On the centralized side, some common tools that are centralized version control systems is CVS, Subversion, and Perforce. Some of the advantages of these centralized systems is the admin behind the server has very fine control on who can do what. And if, for example, you want to remove a person from the repository, when you remove them, they don't have a copy of the code. So you're just blocking access to everything. The second advantage of this is that everyone immediately knows what everyone else on the project is doing. So if I go and make a change to the code, with a centralized system, that change is reflected on everyone else. Like they can see what's happening. There's no local code that I need to push or share. Since we're connecting to the same system, everyone has access to the same copy of the database. Now, this comes with a major problem, which is one of the major reasons why the centralized systems lost some popularity along the years. And is that they become a single point of failure. So that means if the server that you're connecting to fails, for example, there's a power outage, or the hard drive crashes, or it just stops being online, you can no longer get access to the code and share your code with everybody. So that becomes like a major issue, especially nowadays where we have complex systems interacting with each other. So that's why we have now a different type of version control system tools. In this case, they are the distributed ones, in which, as you can see in the previous diagram, you still have a server or a central computer that contains the changes. But you also now, on your own computer, have a copy of the database, a copy of the code, a copy of the history of the changes. So that way, even if that centralized server or computer dies or something happens to it, since you have a copy of everything, you can restore the database. You can restore your changes. And also, one of the main advantages is that you can work offline. You no longer need to be directly connected to that central server. Some of the tools that work this way are Git, Mercurial, Bazaar, and Darks. So as I said, you gain offline capabilities, and it's way easier to restore from failures, since everyone in the project has a copy of the code, has a copy of the history of the changes. Now, this also comes with some disadvantages. One of the main disadvantages is since everyone has a copy of the repository and the history of the changes, these tools support certain actions that will modify the history. Like you can actually rewrite history when using these tools. So if you're not careful, you might end up with a repository and a history that is very different to the central computer or to the central server. And that can cause issues while trying to synchronize both of them. One of the other disadvantages is since when you're working on your code changes, if you see here in the diagram, if you're computer A, you're going to be working on your local version of the repository. So in order to share your code with everybody, you need to keep pushing, to keep sending that code to the central computer. So it is not automatic. You have to actually intentionally send your changes to the distributed system so that everyone can else obtain those changes, which is called pull. And I'll go into these details once we get to the examples. So before I go to the next section, any questions so far on the tools and centralized versus distributed?
Is the distributed, the server computer is usually on the cloud, right? For at least for Git, it's
Right. Usually companies set up their own version control system, and usually you have to connect to it. They will give you access credentials. But also there's online, there's many services, free services you can access, like GitHub and Bitbucket. So those are two websites that you can sign up on to host your own projects and share your projects to other people. So the next question is, why should I be interested? Why do we need a version control system? Well, the main advantage or the main reason you need a version control system is mental sanity, especially when you're collaborating with more than 3 people. Having coordinating among developers on what changes should be added, removed, or sometimes being able to work on a feature and then bring it back or add it to the main code base requires a lot of coordination to do it correctly. So without a tool, it usually becomes a big mess. If you don't have a tool that will help you share code with your colleagues, and you will end up everyone will have a different code base. There's going to be changes that you made that are going to be missing, or someone is going to be forgetting to merge or to get on their own version of the code. But more, so it's about, and also with a tool, when things go wrong, there's like a history you can rely on. So you can revert some of the changes that you made, and you can visually see on the tool who changed what, and you can undo the changes, or you can bring those changes to other sections of the history. So the main thing is that it will empower you to understand what's happening and who's making the changes. Now, the third point is, it's obviously definitely a great icebreaker, right? When you go to a restaurant, to a bar, everyone wants to hear about what version control is and Git. So I think that's one of the major points. Now, seriously, Git specifically, it's an industry standard. So if you're going to be working of any type of project where you're going to be modifying code, it is highly likely that you're going to be using Git. So in general, how does it actually work, right? You're asking, okay, so we have this tool that will do things for me, but how does it work? So while I'm gonna get a little bit on the specifics at the end on how does it work internally, I put this XDC picture here because it is kind of true. You will know how to use it, but internally it uses like a graph theory tree model. So not everyone gets to understand exactly deeply how it works until many years later. On the positive side, if you memorize the commands that you need to use, you can get started and you can start taking advantage of it, even if you don't understand completely what's going on behind the scenes. So yeah, this is Git. It tracks collaborative work on projects through a beautiful distributed graph theory tree model. Cool. How do we use it? No idea. Just memorize these shell commands and type them to sync up. If you get errors, just save your work elsewhere, delete the project, and download a fresh copy. So anyone that is getting started with Git will probably feel will feel a little bit like this. But don't worry, once you use it for a couple of weeks, you should be able to understand how to share your code with everybody and how to get your changes. Now, the solving conflict resolution might take a little bit more time. Now, what I'm going to showcase here is some of the popular tools that we have for interacting with Git. On the left side, you'll see that it's more of a terminal interaction. So you don't even need a desktop environment to use Git. If you can even log in to any server using the terminal, and you can actually like make commands, save some of your work on the server, retrieve the changes from everybody. Like Git is not limited by a specific program. Git is more like a tool that some programs can reuse and show you a really nice interface to interact with it. So on the left side is how it was originally implemented, just a terminal, bare bones. On the right side, you'll find which is one of the most popular tools for Git, that is called source tree. So I think enough talk. Let's actually try it out. Let's get our hands dirty. So what I'm going to show here, what I have loaded here, let me share the screen. here. So what you can see here is first Android Studio, and second below it, there's the terminal. So what I have here open is just a bare bones project with a few screens. Now you don't need to understand Android to use Git. I'm just using it as an example of some of the tools that you can use during your development. So first of all, if you see here, we have a few files in this directory. The directory is called BCS sample. And that's the same that you can see in the visual tool. As you can see, you have app.idea, gitignore, gradle.w. There's like a few files that we have in this project. So the first thing you need to do with Git is initialize Git. So what you're basically doing here is if you have installed Git, in this case, I'm doing the terminal version, is you do git init and that will create an empty repository. So what you're telling is, let's start the database. And right now it's going to be empty. So all these files you have over here are not being tracked. Right now, you're still not adding them. You still don't have them in version control. So one of the first things you can do is just add files. So in this case, you can go ahead and get all the files in the current directory. Now, I haven't used the terminal in a while, so I might be a little bit rusty, but here it is. So the instruction that I haven't added, that I have made here is whatever files we have in the current directory are going to be added to the repository. So we're going to start tracking changes. If you see the status, at any point of time in the terminal, you don't know what's happening, like you don't know if you have added a file, if you have committed changes, you can do a git status. So git status on the terminal will show you what branch are you on. I will explain a branch in just a minute. If you have committed, which means saved or persisted any changes, and what is currently the current changes that you have yet to save. So as you can see, the first part is this master, a branch. So before I go and do any more commands, I'm going to show you visually what is a branch. So a branch is, in shorthand, I think it's easier to see it here. Let's do an analogy. Let's say that you believe that multiple universes exist, right? You can branch out of your current universe. Oops. You can branch out of your current universe and create a copy. So you're basically in a branch creating a copy of your code. And the idea is that you're going to be working on this copy and you're going to be making changes. The changes are going to be called commits. So if you see here, think I need to share the whole screen. I'm sharing still Android Studio. Let me go ahead and share the whole desktop. Okay, can everyone see the visual that I have of Git branching strategy?
Yes.
Okay, yeah, I'm sorry. I think it was not being displayed before. So here we have master, which is a universal name. It's a common name that you will find on projects to indicate that that is like the main copy of the code. Master is the ultimate source of truth for so whenever you're gonna release code, when you're gonna release a version of your project to the public, it usually will come from master. So as you can see here, there's what is called version 0.5, and there's version 1, like afterwards. So that continuous line of blue dots represents one branch. So that's like one universe, like that's one copy of the code that moves forward. So on this branch, whenever you want to release your code, you're gonna make like a snapshot, let's call it. You're gonna make a commit. Basically 0.5 in this diagram means that you have enough changes to make a release of your code. Let's say that you're building an app and your app is a contacts application, right? Like the phone contacts. So 0.5 means you're still developing it. It is not feature complete. Maybe you now have a list of people that you can display. Maybe you have a screen where you can add a new person, but that's it. So version 0.5 in this branch means that you're releasing to the public, and that's why you have version 0.5. If you see afterwards, there's like a blue dot. That could be that you introduce a change. In this case, hotfix, the red dot over there, means that before making a release, you identified that there was a defect on your app. So you're making a hotfix. You're grabbing your code, you're fixing a bug on your code, and then you're saving the changes. So a branch, if you see the hotfix, is like on a separate line below. That separate line below means that someone branched out, make some changes, and then merge back into master. So basically someone deviated from the main code, and then when they finished making their changes, they requested those changes to be included into the main version of the code. And as you can see here, there's other branches. There's develop and there's feature. So I will not go too deep into the branching strategy since that's somewhat of an advanced topic. But what is important to remember is that with branches, you can organize how your code is merged back into the code base. So you might have a branch for code that has been deployed to production when you release a version of your app. And you might have a branch that is all the new features that you're working on that you don't want to release to the public yet. So that's why you have it in a separate branch. It's like an alternative universe that you eventually are gonna converge and merge into the main code. So coming back here to the terminal, I'm currently on branch master. I have a few files that I want to add to my initial project. But these files I haven't committed, which means I have worked on the changes. Git knows that I have changed things around, but I need to tell it explicitly to save the changes, to save a snapshot of the changes so that I can share them with everyone else. So in this case, I'm going to do a commit by hand using the terminal. So in this case, git commit dash message. So what I'm doing is I'm persisting the changes that I made, but I'm appending a message to them so that someone knows in the history what's happening. So here I have added the initial project files. In this case, since it's a new repository, you need to tell Git some details about yourself so that whenever you go into the history, you can see what is the developer that made what changes. So I'm going to run these two commands that is asking me to do. So the only things you're going to need to tell it is any username and any email. Now I'm going to run the command. So if you go back and see the status, you're going to see that the files that were previously marked as changed are saved. So as you can see here with the git log, whenever you make a change, you can see who did the change, the date, and the message. And there's other commands that will give you even more details. Now, since the terminal is a very outdated way of working with Git, and nobody is expected to work with the terminal anymore, I'm going to go into the programs that actually help you do all the same things that I'm doing here with the terminal, but in a visual and easy to use way. So out of the tools that are available, I'm going to show you one of them, which is inside of Android Studio itself. Many of these tools are going to have a similar interaction. So if you learn how to use one of these tools, you're going to, whenever you use a different tool, you're going to see that it works or looks very similar. So in this case, Android Studio has a few buttons over here that are enabled only when you have a project with a version control system already set up. So in this case, since I did it with the terminal, I initialize the repository and make a change. Android Studio already detects that I'm using Git and that the repository has been initialized. So that's why you see this Git section over here. If I were to start a new project, if I were to start a new project with Android Studio, and that means it will be in a different directory, by default, it will not come with Git or version control enabled. So if you see, this is the new project. On the top right, there's no Android Studio in there. I mean, there's no Git in there. So what you do is you go into version control system, and then you enable version control integration. Here you have a few options. In this case, you can select Git. And this is similar to what we did in the terminal when we did Git init. If you see here, it's very similar to a Git init command. The advantage of the tools is that you don't have to remember what the commands are. It will do things for you. So as you can see, it created by default a branch named master, and it has an interface for you to do other branches if you desire. So I'm going to go ahead and close this project. I'm going to continue on this version control system sample. So one of the first things you can do once you have your version control system initialized is you usually shouldn't make your changes on master, especially if you're working with other people, since master is a branch usually where you do code releases. Like whenever you're going to create your version of your app, you have version 1.0, 2.0, etc. Usually they come from master. So what you're going to do is here on the bottom right, Android Studio has a section where you can create another copy of the code that you can rework and then merge back. So in this case, I'm going to name it Erick. I'm going to call it awesome feature 1. And here, if you see, there's like this is like a copy, exact copy of master. It took master and they made a copy. And I'll show you an example of what does that mean. So far, any questions before I start committing changes? Any questions so far in what I have showcased? Okay, looks like there's no questions so far. So I'm gonna go ahead and I'm going to create a new file. So in this case, I'm gonna go ahead and do a new Kotlin class. So whenever you're working inside of Android Studio, it will detect when you're adding any file to the directory, to the folder you're working on, it will detect that you added a file and it will ask you if you want to add it or not. So in this case, I want to add it. So this is very similar to what we did in the terminal where I did git add. With git add, you can add all the files that are currently in the directory, or you can git add and put any specific file in there. The advantage of a tool for version control is that it will do things for you. So it will make your workflow very easy. So here I'm going to create a function that does nothing. Actually, I'm going to do something. I'm going to create a function that receives a number two numbers. E is int. E is int. Okay, so I'm creating a function that receives two numbers and that returns a number. So here you create a new file and you have a little bit of code inside of that file. As you see, this file is highlighted in green. That means Android Studio knows, or the version control tool inside of Android Studio knows that you create a new file. If you just modify a file, it will be in blue. So here, let's say that I don't need this code anymore. If you see a file that is already existing, when I go and modify it, it will be highlighted in blue. So, okay, so I made changes. I have my new awesome feature already ready. So the question is, what do we do next? So once you're ready and you have your amazing feature, what you do is on the top, there's three arrows. The first one is to fetch, to retrieve the changes, to pull the changes from the central server. We go back to the diagram that we had before. This is a distributed control system. So you have a centralized computer that has everyone's code, and you have a copy of the code that you have modified. So with the blue arrow over here, you're downloading the latest version of the repository, and you will try to combine that with your local changes. So if everyone make a change, they upload it to the server, and then you downloaded that copy. Since what we're doing is we want to save the changes that we made, you're going to click here and commit. So this interface, as you can see, it will show you what you changed. If you go into calculator and double click it, it will show in green the code that you added. If you click on the file that you modified, not that you created, but that you modified, you will see how it was before and how it looks like after your changes. So that is extremely useful when you're analyzing what you modified or what someone else modified. In addition, there's a way for you to see annotations, which means you can see who modified the code and when. So those are like some of the most important reasons why you need a version control system. You can see what the changes are, who made the changes, and you can save your changes or undo the changes depending on what happened or what you need to be done. So right now, I like the changes that I did. I'm ready to release a feature. So once you see the changes and you agree with the changes, you can now go ahead and click either commit or commit and push. But make sure that you always put a comment related to what the changes you did are. So in this section over here, you're supposed to put a small message explaining what the changes are. So here I added a new file, and So you added a new class, you added a new function. Or you can just, if you want, you can actually just call it like this. So you added a new feature. So what I'm going to do is I'm going to commit. If you click commit, that's going to do is going to save your changes inside your own computer. You're modifying only your local database. If you want to share the changes with somebody else, you need to go into GitHub, Bitbucket, or a different website or computer and create the central server that you're going to be pushing the changes to. So one of the beautiful things about this tool over here is that you can see the history. So if you go here, there's a Git section where you can see the branches and the history inside of those branches. So if you see on master, my changes are not there. But instead of awesome feature, which is the branch is a copy of master, you'll see the original change that I saved right now. And here on the right side, you can see like what are the files that got modified. And you can click on them and once again, see the differences. Any questions so far on how to add files to the version control system and how to save those changes locally? Okay, since there's no questions, I'm gonna go to the next section, which is conflict resolution. So what happens when you make a change, when two people, even yourself, make a change? For example, when you delete a file and when this person modifies the file, or when you make on the same function, on the same code, different implementations. So let's say that I was assigned to implement awesome feature 1, which is right here, the sum. And then let's say that some other developer, let's say Joel, and he was also assigned to create awesome feature 1. Oh, first, let me redo this. Next, I need to check out master. Let me see. So master still doesn't have the version control system. Let me fix this real quick. Okay, so before I go and modify things, I am going to have to save the Git integration files of UnderStudio into master. So what means is on this, branch, I added files that are needed for UnderStudio to recognize that it has version control system. Let me go ahead. I believe I can just go here. Let's see where are my changes. So I can see here calculator. So I'm gonna go ahead, I'm gonna show you how to save your changes to master. So that's what I'm gonna do right now. So we have your changes, your calculator. And I'm gonna go here to master. I'm gonna check out master, which means in this diagram over here, master does not have the calculator feature that I just implemented. So I'm gonna go ahead and merge my changes into master so that other people can get access to those changes. So from master, I'm gonna enable Git, and they should be able to see my awesome feature. I'm gonna click here. There's many ways to bring your changes into master, but right now I'm gonna select the easiest way, which is merged into current. Oh, this file over here, I actually don't need this file. Let me delete, I don't need this file. It will be, this file will be added from my branch. Okay, I guess I'm gonna have to save the file. Give me enable git. I'm gonna commit this file. Here, I'm gonna be manually adding this file. This file was created by Android Studio to know that this project has Git enabled. So I'm gonna add it to the version control system since it's needed by Android Studio. So select it to commit and then commit. So here in the history, this must be a bug since it's not showing it, but I can show it here in the terminal. You'll see the initial change where I added the project files. You'll see here the integration that I just added one more file into Android Studio, the version control integration. So what I'm gonna do is master. This one over here does not have the changes from the calculator class. So I'm gonna go ahead and bring those changes back into master so that we can prepare our code to be released. So I'm currently in master. I'm gonna check out my feature. I'm gonna merge it into the current. So as you can see, what I had inside of this branch, which is over here, different branch, feature branch, is brought into master. So if you go into the project files, you can see the code that I just created. So that's like the first step, how to add code to the version control system and how to make changes and bring them back for everyone to use in master. The next and last thing, since we're starting to run out of time, is how to solve conflicts. So let's say that someone added here new code. So let's say that you have that you were requested that every time that you add, you need to save it, you need to print it. Let me see. So this is just a Java class. I'm gonna need something else to do logging. Let's keep it simple. I'm not gonna introduce any Android code into this function to keep it simple. So what I'm gonna do is, let's say that you have your feature sum, you implemented feature sum, and Joel over here let me delete this. I'm gonna delete here this that is not needed right now. I'm gonna copy the name. Here. So let's say that you were assigned to create a new feature. So let's say that you were assigned to create the multiply feature in your calculator. So let's say that you have this feature that is multiply. Actually, I can give it a better name. I'm gonna call it so this is going to be a branch that is mainly dedicated for adding a multiply function. So right now, I'm going to go ahead and save the changes. So I'm saving the changes of this multiply function. But let's say that I was requested to create a divide. So I'm currently going to base it on master because that's the copy of the code that everyone should have. And while Joel is working on multiply, I'm going to be working on divide. We're working at the same time. So here, I will usually go ahead right here and go ahead and create two numbers. So let's say that I work on my feature. Joel work on his feature. And I got to merge it first. So I'm going to be saving my changes for a division. We have the sum and divide. It's saved here inside of my branch, calculator divide. I'm going to go and check out master. And I'm going to bring to master the changes that I did on the divide. So if you see currently, master does not have my changes or Joel changes. But if I click merge into current, the divide is going to bring my changes into here, into master. So you see this graph, you have master, there's some changes, and we bring them back to master. Now, conflict resolution means what happens when we modify the same line of code with different content in two different branches. So let's say that Joel has just finished his feature, multiply, and wants to merge it into master. This is going to create a conflict. Because if you see here in the same line of code, I put divide and he put multiply on the same line. So the version control system doesn't know which one is the right thing to do. But fortunately, it has this interface over here that you can either override your changes with yours, override your changes with theirs, or merge. Most of the time, you're going to be clicking merge. So here you can see that this is the original master. This is the change that I introduced with the branch, with the feature divide. And this is the new change that Joel is trying to merge or to add to everyone. So in a visual way, you can just go ahead and I want divide, but also I want multiply. So once again, you can tell it, yes, I want this change. And you can even tell it, no, I do not want this change. So if you tell it, I don't want this change, it's gonna ignore it. And this is gonna be the final version of the code. Now for this example, I'm doing Control C. So you can see here we have divide. And actually you can actually copy paste it. You don't even need to do this. You can go and modify here. You can say, I want multiply below it. So once you have solved the conflict, you can go ahead and apply the changes. And now master has the two features inside of it. So that was like a very easy way to solve a conflict. When you have two different versions of the code that do not match, and you're trying to make one version of the code to be able to release your amazing application. So that is the end of my presentation. Does anyone have any question about Git on the terminal, Git on Android Studio, or Git in general?
I just had a really quick question. So when you were using the tool the way you were doing it, does it also create directories on your, like behind the scenes for the different repos, the different branches, I mean? Like one for Joel and one for you, for each of the fantastic features?
So it internally, it will basically go, let me see. So let's say that instead of creating directories that you can see, like if you go to the project files, let me show you the files real quick. So these are the project files, right?
Right.
So if you see, there's a folder that is called Java. There's another folder inside that is called example BCS, and there's like the 4 classes. And this is master, right? So when you're working on a different branch, when you have your branches, the way Git works is it will not create like folders that you can see. So there's no like copies of the code that you can see physically. What it internally does is that it saves a diff. So it saves just the diff, it saves like a file with what is the difference between master and this branch. But that's like internally Git will do it. It has its own database.
Okay.
And you can see, if you are curious, you can see a little bit of what's that, where does it store those changes? If you go and do If you show the hidden directory,
Yeah,
there's here this .git folder.
right.
So inside of that Git folder, you will see internally how it keeps track of the changes and the branches and everything.
I see. Thank you.
Yeah. So Git specifically, thank you for actually mentioning that, is very efficient because you're not saving a copy of the whole code. So you're not like you're not doing like a multiple copies of the folder. You have like master, and then each branch will only save the difference. So in this case, if you have, for example, divide, if you go here to the history, if you see this is like the initial files that I added, right? So when I go and make a change, Git will save only the difference between this and this. So if you see, it saves like this file over here, it saves this change over here, it saves this change. It's a delta what Git saves. So if your project weighs 1 megabyte, when you make a branch, it's not gonna generate a 1 megabyte copy.
Yeah, it's just
gonna-
some metadata basically when you create a new branch and still until you start making some changes,
Exactly.
I guess. Okay,
Yeah.
that makes sense.
Yeah. So that's why like you can have thousands of collaborators online and still have a decent sized project, like a manageable size project files. Actually, one of the curious things is that if memory serves me right, Linus Torvalds was the one that created not only Linux, but also Git. And he created Git to be able to keep track of the code changes to be used or to be done inside of Linux. All right, do we have any other question? All right, it looks like we have no more questions. If anything, feel free to reach out. Here are some of the sources that you can find more details about how to keep working with Git and to better understand what is happening behind the scenes of Git and some additional commands that I didn't cover.
One thing really quickly, Roger left a message in the chat. I don't know if that's too much to get into right now, but
Let's see here. Can you see what he said? I'm still getting used to this tool in Linux. Let's see, how can I load the chat? Oh, here it is. Oh. Okay, I actually haven't seen this. This is news to me.
yeah, maybe too much to get into tonight.
I do remember about the NFTs issue. Oh, but this is specifically to GitHub, not Git, but GitHub, the repository, like the website. Yeah, maybe I'll go through this and we'll try to understand what's happening.
Was GitHub purchased by Microsoft? Is that why they're doing this driver changes? Am I losing my mind?
Let me first stop the recording. Okay.